So nickel metal hydride, which is Nimh, and lithium polymer, which is Lipo. Basic difference is two completely different chemistries of battery, two different constructions of battery. This one has 6 individual cells, similar to what you'd buy at the local supermarket. So tiny little cells. These ones have flat cells, so they're actually stacked up like that inside, whilst these have individual little battery cells. So two different chemistries. This one is, but there's a bit of a grey area there, because when fully charged, these charge up to about 8 volts or somewhere around there, 8 point something volts. So these actually have a little bit more punch when they're fully charged for the first few seconds.
And then it fades off.
And then it fades off. These have consistency, which is why these are the choice used for a lot of RCs, because you have consistent power until low voltage cut off where they stop. Whilst these, they're really well charged at the start and then they taper off almost immediately, and then go down to nothing. So if for races, obviously you're not going to use this, because you'll start off really well, but after the first lap or two you'll be catching up to the rest of the field. There's really no difference. Charging time comes down to the milliamp per hour, so the capacity of the battery itself. So obviously this one will charge faster than this one, but it also depends on at what rate do you charge that battery. So that depends on the charger and the risks you're willing to take there. Because the thing with these is that you have what's called a C rating. So these have a discharge rating. So what that means is that despite the fact that they have 7.4 volts and they're 4,000 milliamp, you still need to have a battery that is capable of powering the system that you've got it connected to. And that's where the discharge rating comes into. So think of the discharge rating as kind of like a fuel pump for the fuel in your car. If that fuel pump is too small, then the car is going to demand more power, more fuel than what the battery can actually deliver. And this can overdrain the battery and it can damage the cells, because the cells are working extremely hard to keep up with the demand of amps and so forth that the car is demanding. So it's very important that you calculate this. The best way to do it is you divide the milliamp by 1000. So in this case we have 4 amps, or 4, times by 25. So that's going to give you a total of 100. Okay, so that means that this battery is capable of delivering 100 amps total power. If your power system is demanding more than that, then this battery is going to suffer. And when it suffers, things like it gets hot, it may even swell. So the cells have been overworked, so they'll actually swell. And that's usually signs that the battery is starting to fail.